Hello, TCA students. Today's lesson is on simplifying radicals. We're going to begin with some vocabulary. Anytime you have radicals, you have a radical symbol. That's the part in the purple. Some of my students like to call it a little house. There's also a radicand. The radicand is the part in the house or under the symbol. The blue B is the radicand in this expression. And the third part is the index. The index is a tiny little number. In this case, it's an N just to represent any number, but it's a tiny little number that kind of fits in that little pocket of the radical symbol. It tells you what root you're taking. A radical expression is in simplified form if two things happen. First, the radicand has no perfect square factors other than 1. Second, there are no square roots in the denominator. Unsimplified radicals aren't wrong, they're just awkward. In mathematical terms, it's like an unreduced fraction. It's just kind of awkward, just kind of like going to work in your PJs would be awkward. Also, it's just not the way we speak. Nobody ever would say, here's your change of the square root of $25. Let's just take a moment to think about the meaning of square root. The square root of 4 is 2 because 4 is 2 times 2. It has two factors that are exactly the same. Square root of 16 is 4 because 16 is 4 times 4. Again, we see those two factors that are exactly the same. So what we're going to be looking for when we simplify these radicals is, does it have any perfect square factors? And I'm going to show you two methods for doing this. The first method is to look for perfect square factors of the radicand. 8 can be written as 4 times 2. And I know that I can also write radicals as the product of its factors. I can call that the square root of 4 times the square root of 2. But I know what the square root of 4 is. The square root of 4 is just 2. So I'm going to rewrite that square root of 4 as 2, but I still need the square root of 2 under the radical. So think about what happened. The square root of 4 was rewritten as 2. It started out under the square root, but we ended up with a 2 that is not under a radical. Then we also had a 2 under the radical. It has to stay under the radical because it is not a perfect square. So that is method 1. In method 2, we're going to look at that 8 and break it down into all of its factors. 8 can be written as 2 times 4, and 4 can be written as 2 times 2. Now, every time you break it down, you're done with the number. We only want to look at the numbers that are left, that can't be broken down into any smaller numbers. They're prime. So we have 3 2's. Anytime you have two factors that are the same, that can come out of the square root as one of those 2's. You need a pair of 2's to get out of the house, is what some of my students like to say. 2 2's in the house can mean 1 2 that comes out of the house. But we have 1 2 left over. He doesn't have a buddy, no partner. So he has to stay in the house. He has to stay in the radical. So we end up with 2 square root of 2, which is what we got in both methods. Let's look at example B. Well, the square root of 50 can be written as 25 times 2. But I know that I can rewrite those radicals separately. Square root of 25 times the square root of 2. But I know what the square root of 25 is. It's just 5. So I have 5 times the square root of 2 as my final answer. Notice we had the square root of 25 here and here, but it was rewritten as just a 5, which is no longer in the radical. The other number, the 2, is under the radical, and it has to stay under the radical because it's not a perfect square. In the other method, I'm going to start with the square root of 50 and start breaking it down. Maybe I know that it is 10 times 5. So I'm done with the 50. I broke it down. The 5 can't break down anymore, but the 10 can. It's 2 times 5. I'm done with the 10 because I broke it down. 2, 5, they're both prime. So I'm done breaking my numbers down. Now I look for pairs. Here's a pair of 5s. Since I have 2 of those, I can bring 1 5 out of the radical. But I have that 2 left that doesn't have a partner. He has to stay under the radical. So my final answer, either way, is 5 square root of 2. Example C is the square root of 75. I know that 75 can be written as 25 times 3. And the square root of 25 times the square root of 3 is another way that I can write that. But I know what the square root of 25 is. It's just 5. So I can write this as 5 times the square root of 3. In the second method, I'm going to break the 75 down. I know that 75 is 5 times 15. The 5 is a prime number, so I'm done with it. But the 15 is 5 times 3. So I broke down the 15, I broke down the 75, I'm done with those. All that I'm left is 3 prime numbers, a 5, and a 3. 1 5 can come out because we have a pair of 5s. The 3 is alone, so he has to stay in the house. He can't go out. 5 square root of 3. Same answer with both methods. In example D, I have negative 3 square root of 32. This one's a little bit different because I have a number outside of the radical, that negative 3. Don't worry about the negative 3, just keep bringing it down every time you do something. It has to stay with you. So the negative 3 stays outside. The square root of 32, I might recognize that that is 16 times 2. And I'm going to keep that negative 3 out there and write that as the square root of 16 times the square root of 2. Keep the negative 3 outside. It's multiplied times the square root of 16 is just 4. So now I'm going to rewrite that as a 4. And that's still multiplied times the square root of 2. Since it's not a perfect square, I cannot simplify it. Now I have negative 3 times 4. Well, that's just negative 12 times the square root of 2 as my final answer. Let's look at the other method with this one. I have negative 3 times the square root of 32. I'm just going to ignore the negative 3 until I get to the end on this one. So the 32, I'm going to start breaking it down. It's an even number, so I know 2 can go into it. 2 times 16. Done with the 32, I broke it down. The 2 is a prime number, so I can't do anything else with it, but the 16 is 2 times 8. I'm done with the 16. The 2 is prime again, so I'd look at the 8. 2 times 4, broke that one down, and the 4 can break down again, 2 times 2. Notice I have lots of 2's in this. I'm going to start looking for pairs of 2's. I can pair up these 2's, and I can pair up another pair of 2's, and I just have one 2 that is not able to have a partner. So I'm going to look at what I can bring out of the radical. Notice the negative 3. It has to stay out there. I can bring out one pair of 2's right here as a 2. And I can bring out another pair of 2's right here. That's going to come out as a 2. 2 2's in the radical come out as 1 2 outside of the radical. So I used everything inside this the radical, everything that broke down, except for that one lonely 2 that didn't have a partner. He has to stay in the radical. Now I just take all the numbers that are outside and I multiply them together. -3 times 2 is -6, and then that times 2 is -12. So I get -12 square root of 2, which is what I got in the other method. You can do these with either method that you like better. I do ask you to show the work as you do the problems on the next page. There are 8 problems to do. Show your work and put those in simplest radical form. Have a great day.